Welcome back to Aurora Tech Channel. Today, I will review the xTool S1 40-watt laser engraver. It's a fully enclosed machine with swappable laser modules, including the 40-watt diode laser, the 20-watt laser, and a 2-watt IR laser, which is more suitable for engraving on different kinds of metal. The working area is 498 by 319 millimeters. The maximum Z height of the stock machine is 42 millimeters, and it can work up to 133 millimeter thick materials with the riser base upgrade. The motion system uses the steel wheels you see on other xTool machines, and the Z-axis is motorized so it can move up and down according to the thickness of the materials. It uses a pin to probe the material to set the focal length, similar to a BL Touch on a 3D printer. It can also engrave on uneven or curved objects by creating a mesh, and the motorized Z-axis will move up and down to keep the constant focal length. The alignment laser is shaped like a cross instead of a dot on regular laser engravers. It doesn't have a camera system, but the machine can keep track of the laser module position in real time. So you can use the cross to make two corners of the material, and the software will draw a rectangular shape for alignment. It comes with some triangular prisms for you to raise the materials to get a cleaner cut. The maximum engraving speed is 600 milliliters per second or 36,000 milliliters per minute, which makes this one of the fastest machines available. It's actually pretty close to the speed of a CO2 machine. The machine supports Wi-Fi when using the xTool Creative Space software that enables all features and also works with Lightburn as a regular engraver. It has a full line of optional accessories, including an air assist pump, honeycomb bed, rotary roller, riser base, smoke purifier, and conveyor feeder that allows you to work with longer materials up to 10 feet. I will be testing most of them in this video. I would like to thank xTool for sending me this machine to review, but before we get started, I would also like to thank FlexiSpot for sponsoring today's video. We use the FlexiSpot E7 standing desk as our workbench, and recently we've added the new E7 Pro. Having this extra desk lets us work more efficiently, especially when testing multiple machines at the same time. The original E7 can support over 350 pounds, and the E7 Pro is even more rigid and it can support over 440 pounds. Both are built like tanks. This is why FlexiSpot is confident enough to offer a 15-year warranty and a 30-day no questions asked return policy. Furthermore, there are lots of different options and accessories for you to fully customize your desk. In fact, I purchased my first FlexiSpot desk with my own money before they ever offered to sponsor our channel, so I am truly impressed by their quality. Be sure to visit their website flexispot.com and use the code to enjoy an extra discount. Other than the machine itself, xTool also sent me the riser base, a conveyor feeder, a honeycomb bed, and an air assist kit. I will start with the machine and the air assist pump. The machine is well packaged. It has two strips for you to lift the machine up from the box. We just need to remove the protective foam and the other items from the machine, including the user manual, sample materials, ducting, power supply, the 40-watt laser module, and some cables. Before we can mount the laser module, there are a few stoppers to secure the X and Y axis and prevent them from moving during shipping. Then, we can mount the laser module and connect some cables at the back, including the power supply, the USB cable to your computer, a USB key to unlock the machine, the air assist, power, and air tube. I will also install the ducting to exhaust the smoke outside. Okay, let's turn on the machine. It homes itself, and it seems the motion system is working normally. As I have a few different xTool machines, I've already installed the xTool software. You can go to their website to download the latest version. As I'm currently using the USB cable, the software will automatically detect the machine and remind me there is a new firmware available, so I will just let it update. After that, if you prefer to use Wi-Fi, you can enter the SSID and password, then search for the machine under the Wi-Fi tab. Let's start with some simple plywood tests. I actually ran the machine to cut the materials to a smaller size for the tests, so you can see there are some marks on the tray. I will start by using the triangular prisms that came with the machine without the honeycomb bed. Instead of a dot, the alignment red laser uses a cross, which makes it easier for you to make sure the workpiece is parallel to the laser head. I will put the alignment cross at the top left corner, and the red cross in the software will be updated in real time. To set the focal length, we can use the probe on the laser head, which looks like a larger BL touch. It will sense the height of the object, move to the right side of the machine to retract the pin, and then go back to the starting position. I will engrave a logo and cut it out using the cross for alignment. For plywood engraving, I will use the default settings of 30% power and a 200 milliliters per second speed, or 12,000 milliliters per minute. For cutting, the default setting is for 3mm plywood, and as I'm using 4mm thick plywood, I will change the speed to 10 milliliters per second, or 600 milliliters per minute, and 100% power. Let's draw a preview frame on the machine. Okay, it looks good, so we can start the job. I really like seeing the circle drop when the cut finishes. The cutting is pretty fast, and it's almost like a 50-watt CO2 laser. The edges are clean with air assist, and the engraving result is also okay. But as the left side was placed right on the triangular prism, the oil of the wood actually left some marks on the back. I will cut another one, and this time there's nothing underneath. The front is the same, but this time there are no wood oil marks on the back. Then, I will cut 2 ninja stars on the same 4mm plywood with the same 10 milliliters per second speed and 100% power. It seems cutting 4mm plywood on this machine is really fast, and the edges are cut beautifully. As the top speed of this machine is 600 milliliters per second, or 36,000 milliliters per minute, I will try to use their top speed to do photo engraving. It took less than 13 minutes and the details look okay. The cutting is clean and the back is clean as well. I will do one more with the default settings. It will slow down to a 200 milliliters per second speed and 25% power. It seems 200 milliliters per second is still pretty fast, but let's do a side-by-side comparison with the 600 milliliters per second speed. The total time of this job is only 2 minutes slower. That's mainly because when the speed is set to 600, the laser head is going way further than the width of the picture to accelerate and decelerate. I think using the top speed to engrave something larger would be much faster. Surprisingly, the 600 milliliters per second and 100% power actually look better in this picture. Then, I will try to cut some thicker wood. Let's stack 2 of these 4mm plywood together. I will start with an 8 milliliters per second or 480 milliliters per minute speed with 100% power. Then, I will stack 3 of them to make it 12 millimeters thick, and I will use a 5 milliliters per second or 300 milliliters per minute speed with 100% power. Finally, I will stack 4 of them to make it 16 millimeters thick, and I will use a 3 milliliters per second or 180 millimeters per minute speed with 100% power. It also cuts through completely, and it's actually really fun to watch this. It kind of feels like I'm watching karate wood breaking. Let's take a closer look. Cutting 16mm plywood in one pass at a speed of 180 millimeters per minute is really impressive. Next, I will try to cut solid wood, starting with half-inch 12.7mm poplar wood. I will start with 5 milliliters per second, as the same speed can cut 12mm plywood. It's very clean, like cutting butter. Next, let's cut this red oak wood, which is denser than cherry and walnut wood. All 20-watt and even some 30-watt modules still struggle to cut through it completely, so let's start with 4 milliliters per second or 240 milliliters per minute. It almost cut through, so I will slow it down to 3 milliliters per second or 180 milliliters per minute. Okay, it cut through entirely this time. If I remember correctly, then this is the only laser module that can cut through this half-inch red oak in one pass at 180 milliliters per minute. Let's try some other materials. I will use a black-coated aluminum card. As this card is small, I will use the machine's marking feature, which requires you to move the laser head to the top left and bottom right of the workpiece. Press the button on the machine to mark the top left, and the software will read the position. Then, move it to the lower right, press the button again, and now the software will use these 2 points to form a rectangle. I will put a QR code logo on it and maximize it to engrave the card from edge to edge. Okay, the frame seems accurate, so we can start the job. The alignment is perfect. For a rectangular workpiece, using this 2-point marking feature for alignment is pinpoint accurate. Let's take a look at the actual card with the software preview, and the result is even better than using a camera. However, for round objects like this Slate coaster, it's challenging to use 2-point alignment. I will show you another way later, but for now I will just use my old approach of engraving the pattern over an area slightly larger than the actual object to make sure it's covered from edge to edge. The pattern looks light from this angle, so let's change it to the top view. Okay, this is how I would normally engrave using a standard engraver. The result is still pretty good, as the slightly larger pattern won't affect anything in this job. But what if we need to engrave a logo that needs to be the exact same size and at the dead center? We can use a ruler and pencil to draw some lines to find the circle center point, and then use the alignment laser cross on the print head to align with the center. Now we can place our object at the center of the cross. Since there is no center point on my logo, I will draw a small circle and change the size to 1mm by 1mm. Then I will use the alignment tool to align it to the center of my logo and group them. Now I can use the tiny circle to align with the cross. You can delete it or just output the logo. Let's start the job. Okay, using this method with the alignment cross, we can also get a very accurate result, and the engraving on the Slate coaster is really nice. Up next, I will engrave on a small PLA plate. First, set the height using the probe. Then I will use the marking tool again, starting with the top left, then the bottom right. With the square marked on the canvas, we can easily position the logo to put it at the center. For PLA engraving, I will use 200 milliliters per second or 12,000 milliliters per minute with 30% power. We can actually make some depth on the plastic. Let's clean it with a wet cloth to remove the white dust. The result of engraving on PLA is surprisingly good. Then, I will try some acrylic cutting. For diode lasers, we can't cut clear acrylic, so I will cut black acrylic. First, I just did a few cuts at the corner to find the optimal speed and power. I found that using 100% power at the speed of 8 to 10 milliliters per second works best. So let's start with 10 milliliters per second. It's mostly clean, but for some sharp turns, I think cutting a bit slower would be better, so let's do another one at 8 milliliters per second. The one cut at 8 milliliters per second is slightly better. Both of them look okay, but when you zoom in closer, the 8mm one is still better. As this machine has a probe like a BL Touch, it can also engrave curved objects. As I don't have any curved objects, I will just make a curved plate in Fusion 360 and print it with the CR10SE, which has actually become my go-to bed slinger alongside the Cobra 2 Pro. We need to select a curve process in the software and start with making the top left and bottom right of the workpiece. Then, it will probe 60 points for this shape. You can do even more if you want a more accurate result, but I will just follow the default values. As the PLA plate is pretty light, I will use the honeycomb bed and the magnetic clips to secure it. It will show a mesh. I will just drag the smoothness and tension to the max and put some vector graphics inside the working area marked by the software. For curve engraving, the maximum speed is limited to 30 milliliters per second or 1,800 milliliters per minute. I will try 10% power and send the job to the machine. If you look at the Z-axis is moving up and down to maintain the same focal length when engraving on different areas. The result is very good. It seems the graphics and text are very consistent despite the surface being curved. I think this could be a good way to put your name, logo, or message on your 3D printed parts. Finally, I would try the riser base on the conveyor feeder. Without the riser base, the machine is very compact, but it can only work with objects up to 42 millimeters. So for example, if I put something that is 50 millimeters tall, it's going to hit the laser head. After the riser base is added, it lets you move the tray lower to fit taller objects. The maximum height is now 125 millimeters, and I put 3 50mm tall blocks for your reference. When using the conveyor feeder, the riser base is also required. So, it can fit objects as long as almost 10 feet if you buy extra support rollers or figure out how to hold the longer materials on both ends. I will just demonstrate this feeder with some cardboard by engraving a tree and cutting it out. As I'm going to cut 8mm thick cardboard, I will set the power to 60%. I tried different combinations off camera, and this setting seems good for 8mm cardboard. Actually, cardboard at this thickness is quite challenging to cut on a lower power machine, as you can't go too slow or it will catch on fire. But using this 40-watt module provides extra flexibility to allow you to cut with lower power and still be able to cut through completely. As this is large cardboard, I will make another tree and a sword to get the most out of it. Okay, with this conveyor feeder, it can make working with objects that are much longer than the machine far easier. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The cutting power is strong. It can cut 16mm plywood and high-density red oak solid wood at 3 mm per second or 180 mm per minute in a single pass, which is the strongest laser module I've tested so far. 2. The machine is fast. I can engrave on wood and slate at 600 mm per second or 36,000 mm per minute. This speed is close to my $5,000 55-watt CO2 laser machine, the P2. 3. The marking feature works well. For rectangular-shaped objects, it can achieve pinpoint accuracy, and the result is better than any single camera system I've tested. For round objects, once you manually find the center point, you can also achieve high accuracy. 4. xTool Creative Space has improved a lot. It has new features like multiple layers, and it's preloaded with engraving and cutting parameters for most materials. I used it exclusively to finish all the jobs in this video without even touching Lightburn. 5. The air assist is controlled by the machine. The software automatically controls the air pump, but besides auto mode, you can also use the knob to adjust the pump manually if your job requires special manual control. 6. The machine is rigid and compact, so its build quality is higher than other laser machines in the market, and its appearance is also super nice. Now for the cons. 1. This machine starts at $1,700, which isn't cheap, but it doesn't include air assist and requires you to purchase it separately as an upgrade. Unlike other accessories like the honeycomb bed, rotary roller, and conveyor feeder, which not everyone needs, air assist is essential for a laser setup. 2. The Wi-Fi doesn't work as well as the F1 and P2, which I had no issues with. For the S1, I did experience some connection issues and had to connect the USB cable and reset the Wi-Fi settings more than one time. So I just switched to the USB cable to complete all the tests. As this machine is new, it's likely due to a software or firmware issue, and I hope xTool will address this in the next firmware update. 3. The marking feature is good for positioning rectangular-shaped objects, but for round objects, I would prefer to see the alignment tool work with the red cross as well, so we don't have to draw a small dot and align things manually. 4. The tray at the bottom is black-coated metal. If you use the triangular prisms that came with the machine for cutting, you are going to leave marks on it. Even if you purchase the honeycomb bed separately, as there is no base plate on the honeycomb bed, you are still going to leave marks on it, so it'd be nice to see an extra steel plate with the honeycomb bed in order to protect the tray. 5. The width of this machine is 30 inches. However, when using the conveyor feeder, it can only handle materials up to 18 inches wide. This size seems a bit odd, especially considering that the most common wood sheets or panels available at places like Home Depot or Lowe's are 24 inches wide. For people who regularly use a table saw, this may not be too big of an issue. However, for people like us, cutting down every wood sheet or panel from 24 to 18 inches before feeding it to the machine can be pretty challenging. That's why I decided to test the feeder with a cardboard sheet. Even though the conveyor feeder may only work on 18-inch sheets, I would still like to see it be able to fit 24-inch sheets. In conclusion, this machine is well made. The build quality makes it stand out from other laser engravers. There were no major issues. The cons I mentioned are mostly suggestions for improvements in design, software features, or fixing firmware bugs. I've tested quite a few laser engravers in recent months, and this machine has exceeded my expectations. I'm impressed by the cutting power, and the working speed is comparable to a 50-watt CO2 laser when working with wood. The 2-point marking feature performs even better than most single camera systems or a DIY webcam setup with Lightburn. If budget is not your primary concern, this is the best fully enclosed diode laser available in the market. On my website, auroratechchannel.com, I previously awarded the title of the best fully enclosed laser engraver to the M1. Now, the S1 will replace the M1 as the new king of fully enclosed diode lasers. If you're interested in comparing the prices and features of 3D printers, laser engravers, and CNC machines, we have a price tracker that updates every hour, monitoring the prices of over 100 popular machines on auroratechchannel.com. Especially with Black Friday and Cyber Monday approaching, you'll definitely want to know which machines offer real discounts and check their price history. I've included the link as well as information about the xTool S1 laser engraver in the video description if you're interested. That's it for this video. If you found it helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.